All right. Yeah, I think we've given enough time for people to arrive. Let's go ahead and get started. So, welcome to the Tech Academy's weekly workshop with me, Erik Gross, the co-founder of the Tech Academy. This is me. I am a senior level software developer. I've got a few decades of experience, as you can maybe see from the gray in my beard there. As I mentioned before, I'm a U.S. Navy veteran. I had kind of an interesting job in the Navy. I was a nuclear reactor operator, of all things. And the specific discipline I had in that whole area is electronics technician. So I got to learn everything from the ground up about electronics and digital circuitry and computers and all that kind of nerdy stuff, which is great. And while I was in the Navy, they assigned me, I didn't ask for it, they assigned me to teach classes, which I was dreadfully frightened of when they first gave me that job, and turned it out to change my life. Absolutely love it. I like to think it comes from my dad, who was a phenomenal teacher. And turns out I have some decent skill and an absolute passion for teaching. And then years later, I co-founded the Tech Academy. We've been around about a decade. We'll talk about them more later on. But that's me with a little less gray. I might want to get an updated picture, but maybe I don't want to. So we have an assistant in the chat. Regina is there. You'll see her in chat, right? And she's there to help answer questions. She's conducted more of these free classes than I have. She's really good at this. And just obviously be a nice person. She'll remove you if you're not. But it's been so long since we had anybody who was a problem in one of these classes. Shouldn't be a problem. Oh, yeah, I saw Patrick's question about what my rate was. It was an ET or electronics technician. Okay, good. Balakrishna, we'll get to that question in a moment. He's got a specific artificial intelligence question. I'll come back to that. All right. So I think at this point, everybody's comfortable with using chat, right? For those of you who haven't done this so far, if this is your first class with us that you've attended and you haven't so far this evening told me, let me know where you're joining us from. We've got people from all over the country right now, which is great. Okay, good. Maryland, excellent. All right. So here's the basic agenda. We'll have a short explanation of the Tech Academy, and then we'll do our workshop, which is all about a day in the life of an artificial intelligence developer. Then we'll have a brief Q&A session, although I do try to pick up questions while I'm delivering the workshop rather than just being me talking at you for a while. And when we're done with the Q&A, we'll go over some information about our boot camps, what they're all about and who they're for. There is a free gift at the end, so please stick around to the end. Oh, Frida's joining us from Denmark. That's fantastic. All right. So the whole class is about an hour, hour and a half. So brief introduction to the Tech Academy. We provide coding boot camps. And if you're not familiar with coding boot camps, they are intensive technology certification programs. They're designed to prepare people for entry-level jobs in tech really fast, like 3 to 6 months. And they focus on practical modern skills, the kind of things that employers want right now. Well, we've been delivering thorough, budget-friendly, flexible, trusted coding boot camps for over a decade. We started at the beginning of the actual industry of boot camps way back in 2013. So our programs are very cost-effective, and they're self-paced, which is kind of unique. They're all delivered online, and they're tailored for beginners, people with no prior technical or coding knowledge. They cover, like I said, in-demand skills. They're endorsed by stellar online reviews, and they're designed to fit around your personal schedule. And we want to prepare you for a technology career with a well-rounded toolkit, so you're set up for success. The average cost of boot camps in America is about $13,500. Ours are under that national average, and we even have boot camps that start as low as $5,300. And I always like to read our mission statement. Those of you who've attended a few of our classes will probably recite this from memory with me. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. Our product is you working in tech. I do want to take one moment to mention a relatively new service from the Tech Academy called the Tech Academy Accelerator. I love this service. It's a monthly subscription program. It's super cheap. It's a monthly subscription program that includes live weekly workshops with me, It also includes over 100 educational videos and over 100 self-paced online mini classes. What's unique about the workshops that we get to do in the accelerator is we do a deep dive into complex technical subjects. They're intended to accelerate the career of someone already in tech. And these workshops, there's a lot of back and forth Q&A. We have open chat and voice. It's very interactive, and we teach topics suggested by the community. If you're involved in this accelerator, if you subscribe to it, you've got a say in what kind of things we're going to talk about. Like just a couple days ago on Tuesday, when we did our weekly workshop this past Tuesday, we talked about how to succeed in the world of freelancing as a technology professional. What are the do's and don'ts? What are the things to look out for? How do you maximize your earnings without going insane and creating a whole second job for yourself? So we covered all of that in great detail. So again, I said it's cheap. It's $9.99 a month. And we even give the first 7 days free for people to try it out. You'll see a link that just dropped into chat. If you're interested in the accelerator, go ahead and grab that link, fill out the form. If you do try this out, you will be asked to enter a card number, but you're not going to get charged. We set up the back end on this really well so that you get a full week to check it out. And it's super easy to say, you know what, not for me. But what we recommend is join for free, attend that first workshop, check out the videos, and you're not going to get charged for that first week. So there's that link. That's the accelerator. I love this method of interaction with people because we can go really deep, answer all kinds of questions, no holds barred, and you get a lot of access to me. And I really, really, really love that back and forth as an instructor. All right. Last thing before we get going here, I want to lay down proper expectations. In these classes, this is not a coding class, but what we do provide is simple definitions for technical terms. We'll explain technology-related concepts in plain English. And like I said, there's no coding. We do have weekly coding classes. So if you look on Meetup, you'll find coding classes. Regina, if you could drop a link to the next class into chat so people can grab it and join us if they want to. And I'm going to get a sip of water while she finds that. All right, so there's that link. While I'm switching presentations, go ahead and grab that. All right. So let's talk about a day in the life of an AI developer. Now, quick show of hands in chat. Drop a 1 in chat if you are already working in technology. Drop a 1 if you're already working in technology. All right, Kim, Heron, excellent. L, awesome. Benjamin, good, excellent. Glad to see that. All right, so the vast majority are not yet working in tech. There's another couple 1s. That's great. Now, drop a 2 if you're working in artificial intelligence. All right, that's kind of what I expected. Got 1 there. Excellent, L. That's fantastic. L, drop in the chat what discipline you work in AI. What kind of work do you do? Oh, good. Excellent. Prompt testing with chat. I love it. Okay, good. All right, so I'm trying to do 2 things with the workshop today. For those of you who aren't in tech yet, I want to paint a picture of what any technology job is actually like. There's some common misconceptions about what it's like to work in the industry, and I want to give you some of the true data so you can honestly make an assessment as to whether or not, working in technology makes sense for you. And part of that is knowing what's the job really like. And then obviously I want to focus in on if you happen to specialize in the artificial intelligence area, what does that day in, day out work look like? What kind of things will you be doing? So we're going to answer those 2 questions. What's it like to work in tech, period? And also, what does it look like if you're specializing in AI? And along the way, hopefully you'll learn some things, both about the industry and about artificial intelligence. Oh, good, excellent. Elle also says she works in voice recognition. That's great. All right, good. So let's dive into this. Just a little brief overview of some concepts related to artificial intelligence. Okay. So artificial intelligence is the use of computers to perform actions that humans would otherwise perform. And in fact, it's the use of computers to simulate an actual human intelligence doing work. So we move away from like the mechanical processing information, like ingesting a bunch of documents and going through and finding everywhere that there might be spelling errors. That's a pretty mechanical action. And instead, we move into something where the human mind really needs to play a part. Things like ingesting hundreds of thousands or millions of images of common everyday items, and then using software to then learn from those images and, given a brand new image that it's never seen, try to determine what that image has present in it. That's not routine mechanical actions. That's a whole nother area of using computers to provide value to human beings. One thing I do want to stress is that computers can't really think. They don't have life in them. They can be programmed, as you're all experiencing with the AI explosion, and as you'll learn more about tonight, they can be programmed to perform actions that very much seem like there's an actual intelligence behind them. But I assure you there isn't. Underneath all of it, it's just a machine. And frankly, these computers can only ever do what's programmed into them. It's just that the things we can program them to do are very sophisticated, and again, produce effects that look almost like there's an actual intelligence behind them. But there really isn't. All right, so let's move on to some of the major components or subcategories of artificial intelligence. One of the ones I want to talk about is natural language processing. Now, natural language means how human beings actually communicate. So this is like written content, text content, or recordings of voice conversations, that sort of thing. Because when you think about like how computers have to talk to each other, there's a specific, exact, defined structure to how two computers would have to interact. Because again, there's no intelligence there. One computer can't figure out what the other computer really meant. If the information that a computer receives from another computer isn't formatted exactly as expected, the receiving computer can't do anything with it. It can't, for example, receive something that has the word London in it, and it's got, 3 N's in the word London. We would all be able to figure out, oh, they're talking about that big old famous city in England. A computer that had not been programmed to specifically look for, hey, is someone going to spell London with 3 N's? If it hadn't been told that, it would receive that word London with 3 N's and have no clue that the computer that sent the information was actually talking about the city in England, because there's no intelligence behind it. We would be able to figure that out. Oh, you probably mean London spelled correctly. So back to natural language processing. There's all sorts of collections of data accessible to computers of how human beings actually communicate. There's trillions of chat and text and email messages. There's trillions of, lines of written content, all accessible around the internet. And so what natural language processing is working with that kind of data to, one, analyze it for what's the meaning behind the language, or two, how could I ingest all of this data and then produce new written content that looks very real, that reads like natural language. So it's a gross simplification of natural language processing, but you can see how that's an artificial intelligence area. Now we're having computers emulate real human behavior. Another area of artificial intelligence is called computer vision. Now, computer vision doesn't necessarily mean using some sort of a device that can observe the environment in real time and see what's there, although it can encompass that. But it also includes using computers to look at static images, pictures, diagrams, that sort of thing. The whole point here is that computer vision is the use of computers to look at images and analyze them in much the same way a human being would. If you think about looking at a picture that in the foreground has a nicely set, dinner place set, with the, plates and silverware and all that, and a candle, and then in the background you can see rolling fields and, in the distance there's a castle and that sort of thing. Right? We would be able to look at that and we'd probably actually be able to spot where the table is. And it was in fact a table. We'd be able to spot, oh, these are plates, right? Those round things here are plates, but in the distance there's a round thing. Oh, that's a circular pond with a concrete border to it. We would instantly be able to differentiate between these things. Computers, unless they're specifically programmed to do so, won't have the ability to look at an image and figure out what's going on in it. So this is the whole area of computer vision, is working with images, either static or real-time processing, say of video feeds, and being able to analyze what's going on inside these images. Another area of artificial intelligence to think with is machine learning. Machine learning, it's actually pretty cool. It's the idea of taking a computer and using it to be able to to perform calculations it wasn't already explicitly trained on. In other words, you're going to feed it a bunch of data, examples of information, and examples of things that can be done with that information. And then you're going to say, okay, good. So you got all that, Mr. Computer? Here's a piece of information you have not yet been trained on. What's the next thing that you could do with this? What logically makes sense? So you can produce behavior out of a computer that it wasn't explicitly programmed to do. And that's a next level use of a computer. It's pretty cool, right? And then the whole other area is robotics. This is the software hardware interface. This is the use of an actual physical universe object, not a piece of software, but a physical universe object to perform physical universe actions that have intelligence behind them. Let me illustrate this a little bit. Robotics for many decades meant performing exact patterns of physical movement and actions that were pre-programmed. So for example, you have a assembly line that produces cars. And if you've got any kind of a concept of assembly lines, you know that the thing being worked on will move through stages on the assembly line. So that's the way we say we get to the point where the doors are going to be put on a vehicle. Well, a robotic arm could be programmed with the exact needed sequence of movements to grab a door from a pile that was right next to it and then position it right inside the actual proper opening in a car chassis and then produce welds at the right place it needs to attach the door. But that's a series of pre-programmed, exact, repeatable actions. That's not where artificial intelligence and robotics meets. Artificial intelligence robotics meets, where they meet, now you have a physical universe thing like an arm or a walking humanoid or those super frightening like robot dogs that can actually interact with their environment and produce self-determined movement or actions. Now, they're not self-determined because an intelligence did them. It's just that the programming in them says, hey, here's some guidelines on how to read what's going on in your environment and some possible things you can do. And here's, put that robot into the environment and it will figure out what the appropriate thing is rather than operating on predetermined movements, pre-programmed movements. Robotics is pretty wild. All right. So there's another word here called cognitive, which means of or related to how the brain or the mind works. So one final subcategory of artificial intelligence to talk about is cognitive computing. This is the use of computers, and in fact, giant networks of computers, to emulate what we know about how the pathways inside the brain work and how the thought process works. It's an attempt to replicate inside of these mechanical machines called computers how the mind works. So, for example, you might say have 50 or 100,000 computers all connected up to each other, and each separate computer acts as a tiny element of a brain. But taken in aggregate altogether, you can have the whole collection of computers look at data and operate much like the brain does. This is the whole cognitive computing area. And there's some really wild things going on in there. So on this slide, I know it took a little while to get through this, but I just want you to understand some of these subdivisions because one, if you're thinking about being an artificial intelligence developer, you're going to want to know about the broad categories. And two, later when we talk about what the day-to-day work might be like, you'll have some sort of framework for, oh, so there's these 5 or 6 different key sub areas, and I might be doing daily work in one of these areas. You might be working machine learning. You might be working computer vision. You might be working natural language processing. So let's move on. And let me get to the bottom of the chat here. Good, excellent. I've already provided enough examples of natural language processing where you're working with text data that represents how people actually communicate, right? But I want to give one example. Let's say you are an e-commerce site and you for years have had chat interfaces where your customer service reps can communicate with potential or current customers. And so you have this vast database of real interactions, text interactions, chat interactions back and forth between customer service reps and your potential or actual clients. An artificial intelligence engineer who specializes in this natural language processing might be able to take in, build a computer program that would train itself on all of that data and then monitor in real time all the currently occurring chats. And when it sees an indication inside there that the words the customer are saying indicates they might be unhappy, notify someone, notify the customer service rep instantly. Or if the words and sentiment, the emotion behind what the user, the potential customer is saying, indicate that they're actually super interested in buying certain things, it would surface those and it would do it in real time, monitoring hundreds or even thousands or tens of thousands of conversations all at once. There's an example of how it might be done. Another example, the ones that we're all quite used to now because of the last year and a half worth of chat GPT mania, is being able to say, hey, here's a specific type of article I would like to write. And here's an example of how I write. Here's a subject. Please generate an 800-word article that is on that subject in my style of writing. That's an example of working in natural language processing. All right. Computer vision. We talked about this a bit, but now that we're getting into like what a developer would do, very often computer vision, like I said, involves being able to look at an image and figure out what's inside it. This is one of the cool areas of artificial intelligence where the beginning stages of your work in this area have to involve humans. And what I mean by that is, let's say you've got, to make the scale really small so you can kind of think with it. Let's say you have 1,000 pictures, and in those 1,000 pictures, in each one is a cat. And you would perform a manual process where you would program rough guidelines of what a computer should look at inside an image. They would tell it there might be a cat there. And then what you do is you'd actually feed these pictures one at a time into a little training program. And the training program is designed to say, hey, computer, do you think there's a cat in this picture? And every time the computer got it right, you'd say yes. And every time the computer got it wrong, you'd say no. And this program would start to learn to identify whether there's a cat in the picture or not. It's this manual, actual human training process. And there's a lot of nuance to that. There's a lot of complexity that's way beyond the scope of what we're talking about. But that would be a real thing that you would actually be involved in terms of computer vision. And then later on, when the model is really smart at identifying cats, now less and less human interaction might be needed. So that's computer vision. Let's talk about the concept of an algorithm. Again, some of you have not worked in technology. The best way to think of an algorithm is just a solution to solve a problem. That's what an algorithm is. Now you can get really nerdy about this, and if you watch any YouTube videos that are put out by colleges, don't do this, by the way. If you watch YouTube videos that are put out by computer science departments, they will have such a complex description of algorithms, it'll put you to sleep in about 3 minutes, right? All it is a solution to a specific problem. So, for example, if you have the problem that you've got a bunch of student records and they are all in random order, and you need them all to be put in order of grade point average from highest to lowest, you would write a little teeny algorithm, a little recipe, a little solution to that would be able to take the whole collection of student records and sort them in descending order according to what the GPA was and grade point average was of each of those students. That would be an algorithm. You have a problem, and here's the solution for it. Now, it must be a problem that a computer is capable of solving, but that's all an algorithm is. So how does AI use algorithms? Well, the problems to be solved in the artificial intelligence space, again, generally revolve around, well, here's a problem where we need a computer or a collection of computers to work together to perform something that simulates human intelligence. Again, a good example would be analyzing images to figure out what's actually in the image. That simulates real human intelligence. So you'd write algorithms that would be able to scan through an image and identify things that look like they are one entity, like a table or a car or a cat or whatever, and then be able to map that against a known collection of entities and go, oh, well, this kind of resembles a car. The algorithm identifies, oh, I think this is a car. Okay, good. The algorithm did its job, and then you'd step in and you would confirm, if you were in the manual testing phase, hey, computer program, or more precisely, algorithm, you got it right. So this is how algorithms, in general, work in AI. All right. I've done enough about machine learning, right? This is the idea of being able to train computers to perform actions they weren't explicitly programmed on, right? One of the cool things I want to mention is that students learn all about machine learning and all other artificial intelligence topics on our 16-week AI developer bootcamp, which is awesome. More about that later on, though. All right. Now, I don't know why my animations on this aren't good, and I apologize. So let me just pop them all on here. There we go. Okay. So remember I said at the beginning of this that I'm going to try to solve two different things here. The first one really is like, what's it actually like to work in technology, just technology in general? One of the common misconceptions is that you're going to spend all of your time coding, like actually click, 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 writing on the keyboard. In fact, I'll never forget this. Is about 9 years ago, I had a friend who was really bored in his job. He was an accountant and he just couldn't do it anymore. And I was talking to him about possibilities. And of course I said, hey, you're a bright person. Have you thought about getting into technology? And he said, my hands really hurt when I type a lot. If I type for more than 30 or 60 minutes at a time, my hands hurt. So I could never be a coder. And it broke my head, because I never, for the life of me, would ever have thought that anybody would think that as a developer, you would be typing rapid pace for an hour straight. I have never once ever in 40 years of programming ever done that. But again, if you're not in the industry or experienced in doing all this stuff, how would you know? So I'm here to tell you, you don't spend most of your day as a developer, as a technology worker, actually writing code. Maybe 10 or 15% of your day on average, which is kind of interesting. But what you see here is a list of the kind of things that you do that do keep you busy if you're working in technology. Obviously, you do write code, you do build technology solutions to solve problems, but there are also a lot of meetings. In most organizations, they're not stupid waste of time meetings either. You do have to spend some time on reporting and admin. You also have to spend time building and maintaining what's called infrastructure. The simplest way to explain infrastructure is it's every technology thing besides your actual program that's needed in order for your program to even do its job. You write a computer program that represents a website. Well, guess what? It needs to sit on an actual computer somewhere. That computer it's sitting on is infrastructure. That computer it's sitting on needs an operating system. The operating system is infrastructure. That computer your program's sitting on needs to communicate with other programs. So you need networking ability, communication tools for back and forth communication. That program, that website or whatever that you built probably needs to access stored data somewhere. So you need a database. That's infrastructure. So again, it sounds like a simple definition, but it's very accurate. Infrastructure is everything besides your program. So I hope you can see that a developer would also need to be experienced and working at building and maintaining all these other things besides their program. Obviously, you're going to spend some time helping your team and building the actual software. You're going to have to do that. And time spent debugging, figuring out what's wrong with it. Because I'll tell you what, if you've watched any of these tutorials anywhere, any training provider, if you've watched tutorials, they're awesome. I've made a lot of them, but they give you a false picture in one respect. Everything always goes perfect in a tutorial. What they aren't showing you is, what they've edited out is everything that went wrong while they were making the tutorial. Because I can assure you, there's about 5 things that go wrong for every one that goes right. You're going to have to debug things. It doesn't work right out of the gate, and you got to fix it. So these are the kind of things, these 7 items, that would keep a developer busy, whether it's working in artificial intelligence or not. And again, I just wanted to show you there's a lot of elements to the day in, day out work in the technology industry. We're going to look at each of these in a little more detail with an eye towards the artificial intelligence area, but these same 7 things would apply to almost any technology job. These are the kinds of things that you're going to be involved in doing. All right, let me get a sip of water real quick. All right, so if I said that coding might be around 10 or 20% of your time, let's talk about the high level kinds of things you would be doing in coding. These 4 types of work are generally accepted and agreed upon in the industry. That would be coding out a feature, coding to correct a defect, coding to eliminate risk, and coding to handle debt. Now, I'll explain each of these in detail. The feature one is pretty straightforward. We need some new functionality in a specific piece of software that makes customers happy. That's what a feature would be. Now, a defect, obviously, like I said, nothing ever goes perfect. This is coding you would do to fix something that went wrong, and you are preventing a reduction in value, because the software industry is all about providing value to the end user. We are doing all this work to make people's lives easier or happier or both. We're providing value of some sort. And so coding work done in this defect area is trying to mitigate reduction in value by removing any issues that would make customers unhappy. That's what defect work is. In other words, handling bugs. Another type of coding you would do is coding designed to eliminate risk or reduce risk. In other words, we want to try to eliminate the idea of sometime in the future a huge reduction in the value our software provides. This would be things like implementing really good security tools or protections inside your software, right? And then finally, debt. Now, this one's kind of interesting. I want to explain something. If you haven't worked in tech, there's these compromises that have to happen. When you're building out a specific aspect of a piece of software, you sometimes are forced to do it in less than the quote unquote best way. Now, best is not a strict definition. The best way to build something is something that works and does what was asked of it. But inside that, there are smarter ways to do it. And one of the bigger things is, are you building the code that you're working on right now? Are you doing that coding in a way that it has the longest potential lifetime without requiring significant changes to the code? That's one big aspect of the quality of your code. If you're writing something and man, a month from now, I've got to come back to this and change something pretty significantly, You're not going to want to do that unless you absolutely have to in the interest of, different business pressures. Ideally, you're going to design it and build it in such a way that it might be 6 months, a year, 2, 3 years down the line before you need to do any significant changes to that. It's just smart, right? But again, you don't always have that luxury. But each time you make a little bit of a compromise in that, you build up what we call technical debt. In other words, you just know that that thing is going to come around sooner or later and bite you in the butt. It's going to be a problem sooner or later. So smart engineers and smart managers of technology workers will let them spend some of their coding time finding these areas of debt and going in and shoring them up a little bit, removing some of that, like, man, we just did this in a hurry. Let's do it a better way now. But I want to stress something, because this is something that if you move into technology, you're going to face inevitably. There's some times where even though you know there's a better way to do something, you kind of just have to bite the bullet and do it a way that's fast, down and dirty, and just gets the job done. It's just the nature of the fact that you're not creating software in a vacuum, all as an academic exercise, and you get to do everything perfect. There's very real business factors, market factors, financial factors, personnel staffing factors that can very often mean you've got to compromise a little bit and not do it the perfect way you want to. If that's something that doesn't sit well with you, it's going to be rough in technology. If you're willing to discuss, collaborate, and make some accommodations or sacrifices every once in a while, you'll do well. But you also have to advocate for yourself and your fellow engineers and say, listen, we're going to do this right now, but I do need some room in a few weeks or a month or whatever to come back and kind of just do this a little bit better, please. And a good manager, a good organization will acknowledge that you've made that compromise and give you that leeway to come back and kind of shore it up a little bit. So this is only one of those 7 items, but I'm giving it a little bit of time because obviously this is where you're writing the code. You go through a boot camp or you go through college or you self-study to learn to actually write code. Yeah, you might only spend a certain portion of your time doing it, but this is where the rubber meets the road. This is like the actual writing of the computer code that solves difficult problems. This is why you get paid really well. All right, so let's move on to another thing you're not going to have to spend your time in, which is meetings. What kind of meetings will you be involved in? Now, again, every organization is different, and sometimes you might have meetings that could have just been an email, as the joke or meme says, right? But there are really valuable, important meetings. One of the biggest ones would be a design meeting. I have a t-shirt. It's very faded at this point. I've had it for a long time. And it says, weeks of coding can save you hours of planning. It's a joke, but it's very, very true. Engineers are problem solvers by definition. We see some sort of technical issue and we immediately jump into, oh, here's how I would fix that. And that's not a bad impulse. If you're drawn to that kind of thing, you see something that's not quite working right, and you're like, oh, let me analyze that and figure out how to correct it. And like, if you like that kind of thing, you'll do great in technology. But the fact of the matter is that if you'll step back for a minute and take stock of the bigger picture and have a little bit of back and forth discussion with your peers, with the business, with people that understand the problem we're trying to solve really well, and plan out what you're going to do before you start writing code, it's so beneficial in the long run. And so you'll have meetings that are design meetings. What does this feature look like? What's the user experience going to be like? Why are we actually solving this? What are the business factors involved, right? Those are important. Then you'll have work planning meetings. You might have a team of 5 or 10 engineers, right? All working on some sort of big piece of software or multiple pieces of software. It's important to coordinate who does what and when. So you'll have work planning meetings. Otherwise, it's just every man or woman for themselves and there's no overall coordination. You might be called into client-facing meetings. And this is an aspect of the job that some engineers like, some don't. I happen to enjoy it now, although I didn't always. But I can tell you this. There's no substitute for actually hearing from the end users, both what they need and the problems they're trying to solve, and 2, their unfiltered feedback on what you actually made. there's nothing more valuable than hearing from the people that are actually using it. So you might be called into client-facing meetings and have to do those. And then there's change management meetings. When you have in a lot of companies, there are dozens, if not hundreds, of pieces of software all at work, both for internal tools and external software needs for clients. And that's a lot to manage. And so you might have meetings to coordinate, hey, when are we going to actually release, this particular feature? Is there something that we want to have released first? How do we plan and coordinate all this? And again, all of this is separate from actually doing the coding, but the meetings are important, right? Now, I also mentioned this reporting and admin work, right? Oh, hold on. I wanted to give an AI-centric thing. I messed something up here. Okay. So remember when I said the coding's 10 or 20% of your time? I want to mention for the artificial intelligence area, some of the actual kinds of things you might be building or doing, right? So let's take a look at, for example, that natural language processing area. Let's say you're an artificial intelligence engineer or developer, and you happen to be working in this natural language processing area. Some of the coding work you might be doing, the actual technical work, would be like developing a model, which is grabbing all of this, text data that represents natural language and putting it in such a condition that it can actually be analyzed and used to predict future text. You might do data handling, where you're going to go through and make sure that everything is, handled in terms of typos or structure of sentences. You might create tools that'll actually parse that data, go through it and do things like sentiment analysis. Like, this chunk of text, does it imply a positive outlook or a negative outlook? Does it imply an emotion of excitement or an emotion of fear, right? These are kinds of tools you would develop, right? Take this, another thing might be what's called named entity recognition, which sounds all fancy, but it just means going through a bunch of text and being able to have the computer program pick out, hey, when are they talking about a specific city? Like, remember they said nouns. A noun is a person, place, or thing, right? A named entity. Is this section of text, addressing a named entity like London or Bob Jones or Cadillacs, right? You wouldn't be able to, or cars. You would build tools to be able to read through huge amounts of text and identify named entities. And you might build tools, this is important, you might build tools that would implement control as regards ethical use of computers and artificial intelligence, or controls that try to eliminate or mitigate bias in the use of the artificial intelligence tools. There have been a lot of really big stories in the news over the last few years about these models, these sets of data and the operations you can do with them that seem to indicate bias, both maybe, racial bias or gender bias or whatever. And so you might be involved in building tools that would mitigate that. This is some of the actual coding that you would be doing. And the same kind of thing applies to computer vision or machine learning, right? You'll build tools that will aggregate all the data that you need to train on. They will actually do the training, and tools that will analyze the output, right? These are the kinds of coding work you will be doing in the artificial intelligence area. So I forgot to that, and so I wanted to go back and fill that in for you. So thank you for your patience on that. All right, so reporting and admin, this is pretty basic. I won't spend a bunch of time on it. You might need to create reports regarding what your work was, what your personal productivity is. You're gonna have to handle emails. You're gonna have to update work records on, I was assigned this feature, and on this day, I get this part of it done. It's just normal communication back and forth that helps an organization operate well. And another type of work you might wanna, might be involved in is updating developer documentation so that you and your peers and anyone new that comes onto the team can actually rapidly understand what's going on without having to verbally transfer a bunch of information. Now, I mentioned infrastructure. Again, this is everything besides your computer program. In the artificial intelligence area, this is everything besides your training models, the collections of data, and computer programs that will do analysis and artificial intelligence work. So it's everything besides your models and your computer programs. So what are those things? Well, one of the biggest ones is what are called graphics processing unit or central processing unit instances. Now, Let me help a little bit here in case that's not something you're familiar with. Look at the computer you're on right now. Each of you is in this call on a computer. Inside that computer is guaranteed a central processing unit. It's the brains of the computer. A lot of you will also have a second thing inside the computer called the graphics processing unit. Now, this isn't it's not the thing that controls the whole computer like the CPU does. The central processing unit controls that whole computer. But a graphics processing unit does a really specialized job. And they weren't originally designed for artificial intelligence, but they've become very important in artificial intelligence. They came out of the game industry. They came out of the fact that when you're playing games, video games, there's a specialized activity that your computer has to do that needs a lot of computing power, and that is handling all of the graphics. I won't get all nerdy on this, but if you played any video games, you know that your computer's got to keep up with a lot of changes in what's being displayed on the screen very quickly. And so a whole industry came up around a separate kind of tool, a separate component you can put inside a computer called the graphics processing unit. And what's really cool about this is your CPU, that's in charge of the whole computer, can say, hey, listen, I'm going to take care of almost everything that I need to do inside the computer. But when I need work done that's just handling graphics, I'm not going to do any of it. I'm going to farm all of that work over to this separate processor, this separate brain inside the computer that was installed, and it's called a graphics processing unit. And they're super tailored to handling massive amounts of video content very fast. That's what graphics processing units are all about. Fine. And again, they were created for the gaming industry. But as artificial intelligence applications and use cases have become very popular over the last few years, we found out that those GPU devices, those graphics cards that people pay a lot of money for, are super optimized for handling a lot of the processing, the work with data that we do in AI, which is really, really cool. So here, all of that gets us to this first bullet point on this slide. If you're doing work in artificial intelligence, you need both kinds of processing units, and you need a lot of them. Now, thankfully, you don't need to go out and buy 5 or 10,000 or 50,000 computers with CPUs in them and with graphics processing units in them. The cloud providers like Microsoft Azure or Amazon Web Services, also called AWS, or Google Cloud Platform, those providers, you can rent those CPUs and GPUs from them. But you as the engineer, you as the artificial intelligence developer, need to do that. You need to work with the cloud provider like AWS and say, give me 10,000 CPUs, give me 30,000 GPUs. You're renting those essentially from the cloud provider, and you have to configure all that. I bring this up because that's not programming. That's not writing code. And yet, you can't do your job in AI without knowing how to do this, how to reserve all of these instances, these CPUs and GPUs, and use them to do your computing, use them to do your AI work. So it's a whole skill you have to learn, is managing that aspect of infrastructure. I'm not going to go into a bunch of detail on the other ones. That's one of the most important ones, but you're going to need to, manage things about where do I put my models, my collections of data that I use for my artificial intelligence work. They've got to be stored somewhere. Same thing with like storing objects like images and videos, and we're storing all of your files. You have to have storage solutions, right? You also, again, a lot of the work you're going to do in AI involves tens of thousands or hundreds of thousands of computers all communicating with each other to get work done. So you need networking tools. Things like VPC means virtual private clouds. That means your own reserved section of a bunch of computers that you're allowed to use for your work. It involves things called CDNs. That means content delivery network. This is a reserved chunk of computers whose only job is to host huge files you have, like massive numbers of videos or images or such, and deliver them up to the computers that need them on demand. You've got to be able to manage all of these things. This is part of your job as an AI developer. And finally, there's just a bunch of conventional or non-artificial specific, non-AI specific things you'll need to work on, which is databases, development tools, like tools that help you write your code, security and compliance tools to check for security vulnerabilities, all that kind of stuff. None of these are your programs. They're all infrastructure, but you need to be able to work with them on the daily as an AI developer. All right. You'll also need to spend time helping your team, giving a second set of eyes to debug a specific problem that someone might be having in their work, doing what's called pair programming, where there's one problem to be solved at one computer, but there's two engineers sitting at the computer. One of them is driving, like actually doing the typing and whatever, and the other one is there to help, and you're solving it together. That's pair programming. It's very powerful. Working side by side, every opportunity I've had to do it in my career has been a magical opportunity. I've learned more per unit time than in any other activity. It's also nerve-wracking because how you think and how quickly you can solve things is right there in front of your peer. But I encourage you, if you get into tech, take advantage of every opportunity for pair programming. It's phenomenal. You're also going to need to help your team with training. Maybe there's an area you got super passionate about and happen to have developed some deep knowledge. You want to spread that knowledge. You might have what they call a brown bag lunch. Everybody bring your lunch into the office and we'll sit down and I'll drop a whiteboard and teach you a little bit. Or maybe they do it virtually in a Zoom meeting. Often you just want to talk through a problem with a peer. I cannot tell you how many times there's been something that's just, I'm beating my head against a wall, can't figure it out. And I'll walk away from a minute and just talk to a friend and say, all right, let me just talk through this with you. And 90% of the time, what happens is I start describing the problem to him or her. And about a minute in, I go, oh. So sometimes all you need to do is just be a friendly ear to listen to one of your peers, right? And then finally, you might need to do code review. Someone wrote something up. They wrote a computer program or part of a computer program, and you want a fellow engineer to review it and see if there's anything that could be corrected, see whether it does what it's supposed to. And you do that via a mechanism called a pull request. Not going to dive deep into that, but it's just a way to request that someone else pull your changes. They pull what the work you did and they look at it and give some feedback. So this is all the category of helping your team. Now, I hope you can start to see all the kinds of things you might do on a daily basis and how only a small part of it is actually writing code. And we'll wrap up with one of the last ones, which is you need to actually build the software. This is not writing the code. This is taking that code that you wrote and turning it into something that is an actual executable program, a runnable program that can be installed on a computer somewhere, and you can turn the program on and it does its job. You have to spend time doing that. It takes a finite amount of time, right? One of the most common things you do there is you create what's called a build package. Again, I'm not going to do a super deep dive on this, but when you write your code, you're writing text that looks like English, but it's precisely formatted. It's in a computer programming language. That thing that you write can't control a computer. It needs to be turned into a form that can actually control the computer. And that form is what's called an executable file. It's a file that contains instructions that the computer can understand. So you have to do that. You have to use specialized tools to take your code and turn it into this thing called an executable. And then you might be using code that other people wrote. They call it libraries. Your program might make use of other people's code, so you've got to bundle that together with your executable. And then your program might need assets like images or videos or font files or whatever, and you need to gather all of those together. All of that taken together is called a build package, and it takes time to do this. Yes, there's specialized tools that you use to do it, but you got to take the time to do it and pay attention to it and do it well. You also are probably going to run tests on your program to make sure that it's got, it isn't subject to any security vulnerabilities, right? That takes some time, and it's something you'll have to do. And finally, you're going to want to take the code that you wrote, your part of your program, and you move it through what are called various environments. An environment is a place where your code can live. You might have a place called your development environment where only the developers get to look at it. It's their little playground. But then you might have a testing environment where your quality assurance people can look at a version of the program and go in and beat the heck out of it and run tests on it. And then you might have the actual production environment, which is the place you put your program where the end users actually use the program. These are all environments. And you've got to help move your code through each of these environments. So there's all these things you do on the daily that, again, are not coding, but you've got to do them. And one of the last things I want to mention is debugging. You got to find what's going wrong with the code. Well, there's specialized tools called code debuggers that can let you step through each instruction in your program and see what's going on with it and spot where you may have made a mistake or whatever. You can also, if you're making your programs intelligently, they're going to create a running record, a log, a file that contains each thing the program did in order. So you might need to go back through the logs and go, okay, well, this is what I expected. This is what I expected. That's unexpected. Why is that in the log? What's going on? It gives you some insight into where a problem might have originated, right? You also might spend time creating or working with documents to describe how to reproduce the bug. It's one of the worst things you can get as a developer is, a bug report or a problem report that just says, this page doesn't work. This screen doesn't work. It's not working as expected. You're like, give me details. And one of the most important details is describe to me exactly how to reproduce the wrong thing happening. How exactly do I reproduce the issue? And so you might spend time going back and forth with end users to say, all right, I need explicit detail, because only then can you reproduce the exact set of conditions under which the issue happened, and then you can start solving it. So this is part of the whole debugging area. All right. So the last thing I want to do, we've covered a bunch of the kinds of day in the life things you might do, both just as a developer, someone working in technology, but with an AI focus. And the last thing I just want to leave you with is this, in terms of like a day in the life, and then there's a few more things we're going to do. In terms of a day of life, I just want to communicate like this successful attitude to have as a developer. Whether you're working in AI or not, when you get on the job, the first thing you should do is just find out what's needed and wanted. Don't go in thinking you already know what they want. You will have discovered a little bit of information during the interview process, but when you arrive, find out from your peers, from your manager, what's really needed and wanted, and then just concentrate on doing that well and doing it quickly. In other words, do a better job even than they expect, and then repeat that. I know it's a very simple formula. I know a lot of that's intuitive, but this is the most workable pattern for success in the industry that I've seen over the decades. Is just find out what they need and want and exceed that. Do it really well, do it fast. If that means you need to burn the midnight oil at first and study up on things you don't know really well, whatever it means for you, this is a really good working attitude to have. And another reason I bring this up, I'll leave you with this, is it's true that there is a tremendous talent shortage in technology. It's very true, and it's been that way for decades. And it's not going to go away anytime soon. So you could kind of have the attitude, especially after you get into the industry and have a few jobs under your belt. Well, I'm so valuable to organizations, like they should be thankful that I'm working for them. I don't see a lot of that, but I've seen it occasionally. But that's just not a successful attitude in life. The reason I put this slide in here is just because the working attitude that I've seen, and I don't always do this really well, right? But the best attitude I've seen is, how can I exceed the expectations of the people that have brought me on and trusted me to solve these deep technical problems? So that's a successful attitude. All right. Now, let me switch here and go back. And I want to have an opportunity for a bit of Q&A. I was watching the chat and I didn't see a whole lot, but I want to give anybody an opportunity to ask any kind of questions they have. So drop in chat with questions. I have no problem. I'll watch this for a minute, right? I take a sip of water. If you have questions about AI or just technology developer jobs in general, or the tech industry, whatever you want to know, drop a question in chat. Oh, cool. Rena's going to start the AI boot camp at the end of the month. That's awesome. Oh yeah, Balakrishna says in the accelerator you mentioned how to go about becoming like a tech consultant. Is there, I'm following so far. Is there a question in there, Balakrishna? Drop in a little more data there that I can speak to. I'll be glad to address it. Like go about it. Yeah. Here's what I recommend. I'll give you a brief, like just snapshot. Okay. But one of the smartest things you can do, Balakrishna, literally is just join the accelerator, even for like the 7-week trial, which is going to cost you nothing, and go watch that video. It's already uploaded in the platform. You can watch the full workshop that I did on how to succeed as a freelancer in there, right? I'll tell you the short version is if you're going to take a job, doing some sort of side gig, programming the nights and weekends or whatever you're going to do, right? Take any job where you already know around 60% or more of the technologies that are needed for the job. You're never going to find 100%. There's always going to be some things that are needed that you don't 100% know. So as long as you're a bit more than half, if you know a bit more than half what's needed, grab the job. Second thing, never work on a per project basis where they say, I'll pay you $5,000 to build this website. Never do that. Always charge an hourly rate. Now, I'll go into a lot of detail in the presentation about why, but I'm just telling you, like, don't always go hourly, period. End of story. Like I said, I go into a lot more about that, right? And there's a lot more tips and tricks on how to succeed in that kind of thing. But yeah, if you're at all interested in like side gigs and becoming a technology consultant and all that, I've got way too much experience to that. And I tried to dump as much wisdom as I could and experience, and especially the times I've screwed it up so that you don't have to, into that presentation. That was a really good question. Oh, cool. Patrick says, I'm in the second week of the web developer program at the Tech Academy. Just want to say the instructors are great at helping with code. I need it, LOL. I'm glad to hear that. We put a lot of work into our instructors. In fact, I don't know if you know this, you can't be an instructor at our school if you haven't yourself completed one of the boot camps. Like they know not just the material, but they know what it's like to go through that material. And so they're very understanding and helpful. All right, cool. Asia says, I'm not tech savvy in any way. Me starting this new career would be a complete 360. Would you recommend to do so even if I'm not fully comfortable because of the unknowing and how complex this field is? This is a beautiful question. So I want to repeat the last part of it. Like, would you recommend like going into tech, even if I'm not fully comfortable because of the unknowing and how complex this field is? Now, I'm going to say something that probably isn't going to be that real to Asia or to the other people listening at first, but just bear with me. The field is actually very simple. The field of computers and programming is actually very simple. Now, taken all by itself, that's a not very believable comment. And it's a bit of a jerk thing to say because everything involving using these computers and writing code, I just did a hour-long presentation. There's a lot of complexity there. Here's what I mean. The basic principles underneath how computers work and what goes into a computer program, those are actually very, very simple. In fact, it's a struggle sometimes to get people to accept the utter simplicity of what a computer is and the utter simplicity of what goes into any program. Once those are grasped, though, let me tell you, you can start laying complexity on top of that foundation at a pretty rapid pace, and the student can follow. They can understand. One of the biggest mistakes you can make when teaching technology is to assume too much prior knowledge on the part of the student. We don't do that. And so if you ask this question of like, would you recommend going to tech, even if you're not fully comfortable because of the unknowing and how complex the field is? Yes. If you have interest, reach towards technology, there's a lot of good programs out there. I'm incredibly proud of our program precisely because you don't need prior technology experience. And because we lay in the fundamentals so well that people without any tech experience or coding experience can get very competent very fast. You truly can break into technology in like 3 to 6 months and get a great job. But I'll talk more about that later on. All right. Nancy says, what are the tools for AI development? There's a lot of them. That would actually be a lot more scope than we have inside this presentation. You know what I would do on this, Nancy? I would actually use our good friend ChatGPT and just tell it, hey, ChatGPT, you're an expert artificial intelligence developer. Please tell me about the most common tools you use to do your work. I would just use ChatGPT for that. Because that way, if it's overly complex, you could say, simplify that for me, please. But there's so many tools. That is, by the way, I'm glad you asked that, no, Nancy, because we could do a whole presentation all about that. We could spend an hour easily talking about all the different tools that are out there. So good question. It's just a bit beyond the scope. All right, let's move on. And please do stick around because we've got a free gift coming your way. I think you'll like it. So I want to describe a bit more about the school. And again, this is going to be some big giant sales pitch. I'm firmly of the opinion that we're the right solution for a specific problem. And if you don't have that problem, we're golden. It's totally fine. However, if there's a thing you're trying to solve in your life where we would be a good fit, I want to put our hat in the ring. Now, we've done that by providing 12 coding boot camps. They're fully online. They cover a wide range of tech subjects, including, again, artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. You can see on here, we cover a lot of ground. In fact, we have more certification programs than any other coding boot camp on earth. And here's the thing about it. Remember how I said that we solve a specific problem, and if you happen to have that issue you're trying to solve, we might fit. Our programs are self-paced, but they're also instructor supported. And that opens up a whole lot of flexibility in your life if you're trying to break into tech. Additionally, they're flexible. Students set their own schedule, and you can enroll 365 days a year. So if you have time issues, we can usually work around that. Okay? Our content is well-rounded, and it's in-depth. It's not a casual gloss over of any key subject. You go deep. And it works because we've laid the foundations of these subjects so well. Our programs are affordable. They're priced under the national average. And this part is really critical. Learning to code and learning how to get a job in coding are two completely separate animals. And so every program we have includes both job placement training and job placement assistance. Because again, it's different from learning the technology. You have to learn how to get hired in tech, and we teach you that. And most importantly, I know I've said this before, they're designed for absolute beginners. No tech knowledge or coding experience is required. So you don't have to be a nerd to get through our programs. You might need to be a nerd to understand the stupid jokes I drop in a lot of the curriculum videos, but that's not required. We consistently land on every major coding best bootcamp list out there. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars, and that's based on student and graduate feedback. We're super proud of that. So with all that said, I've got a question. Why would you want to work in tech? I just laid out a lot of data about a day in the life. Now, I know a lot of it may be overwhelming at looking at all that, but I want to tell you, one of the big reasons to work in tech is technology jobs actually have really great work-life balance. There is no 60, 80-hour-a-week jobs unless you're like really unwise about where you work. I've never had to do it, and I've been doing this for decades. Also, remote work opportunities are a lot more common, even in the last few years, than they were in the past. So if that's something that's important to you, there's a very real, way to structure your technology career so you can work remotely. I've been doing it for years. Love it. Another thing about it is it's a really creative industry. Yes, we're working with machines. Computers are, in fact, just machines. But there's so much creativity involved in the design process, discussions with your peers, interacting with potential the end users, the way you design the actual solutions. There's so much creativity. You can take a lot of personal pride in your work. Also, it's a stable industry that pays well. Tech jobs pay really well. I did an entire presentation on this about a month ago, so I'm not going to get into a bunch of like nerdy detail. But for example, our graduates on average make $60,000 a year in their first role. Some are lower, some are higher, but on average, over a decade now, it's $60,000 a year. That's way above the median in America. And it only goes up for there because you get regular increases in pay. Now, all that said, if you look at the boot camp route, there are some barriers to doing a boot camp. I'm not going to lie about that, right? Money is a big one. It costs thousands of dollars for a boot camp tuition. What we try to do to solve that is, one, we provide multiple financing options. Two, if you can just pay your whole boot camp tuition up front, there's a massive discount. Three, we have monthly payment options if you have no credit or bad credit. In fact, we have a tuition option for everyone, for all financial conditions, okay? The big thing I want to say on this one in terms of the money, and I really believe this, it's not some silly sales pitch. Completing a Tech Academy bootcamp is in fact an investment in yourself. You're giving yourself one of the more valuable skills in modern society. People pay good money for things they don't know how to do or don't want to do. And technology hits both of those for most people. They don't know how to do it and they don't want to do it. And so they pay good money for people that know how to. You get yourself trained and you are investing literally in yourself. Another aspect of trying to do a boot camp is time. There's no two ways about it. It takes a while to learn this stuff, right? Now, some boot camps have tried to solve that by forcing people to do what they call a cohort model, which you can sign up, but you don't get to start right away. Everyone signs up and then they all start on the same day and they move through the material at the exact same pace. And in fact, so often you have to do it in person and you have to do it 40 hours a week or more. Now, that doesn't work for everybody. It keeps good people out of the industry. So what we do is we allow part-time study. It means you can study concurrently to holding down a job, and you can set your own study schedule. We try to handle the time factor that way. And finally, to get through a boot camp, you do have to have some technical interest or ability. The fact that you're in this call probably means you have some technical interest or ability, but I want to stress something. If you've ever felt like you're maybe not bright enough or there's something wrong with your technical ability, most of the time it's the technology education material's fault. They're too difficult. And that's because, like I said earlier, some educators assume too much prior knowledge on the part of the actual student, right? So our programs, you don't have to be a nerd to get through them. There's no background needed to tech background needed to enroll. So the question I have for you is it time for a change? Like, are you working a dead-end job? Are you unemployed? Do you want to work from home? You want more time with your loved ones? If these are true, the big question is it time for a career change? If it is, we're the solution. We're career change experts. This bridge that you see in our logo is there because we're the bridge between the average population and technology. We want to bridge that gap. We want to route into tech for everyone. And at this point, we have over a decade of experience of breaking people into tech. As I said, most of our graduates make $30 an hour in their first job on average. That's $60,000 a year. We have over 1,000 graduates working in tech, so it's not isolated. And they work at all kinds of businesses, from small businesses all the way up to the big guys like Nike or Facebook or Uber or Epic Games, right? As a reminder, we have open enrollment, which means you can start anytime. So I encourage you to enroll now. And you can do that here. Well, I'll show you in a minute where to do it, okay? This is awesome. We're still in May. You all are going to be blown away by this. So, for students who enroll this month, they get a 50% off tuition discount if they can pay up front. Also, if you pay up front, you can get a refurbished laptop if you're in the US, if you need a laptop. Also, if you enroll this month, you don't have to pay any sales tax no matter where you live, which is pretty cool. Also, we'll ship you a full set of our coding books, all of our technology books, including Intro to Coding book, our Computers and Technology Simplified book, our Technology Basics Dictionary. We'll send you physical copies of those to help you in your study. And we'll give you our career planning guide. The wisdom that we put into this is invaluable. It shows you once you graduate how to plan out your first 3 years in explicit detail. What exactly to do during the first 6 months, what to do during the first year and a half, what to do during the first 3 years to really set you up for a successful career. So we don't just get you into tech, we show you how to navigate your career afterwards. We also give you 90 days of free access to the Tech Academy Accelerator that I was talking about earlier. So you get advantage of all those weekly workshops, Q&A with me, right? And finally, this is huge, unlimited job placement until you land your first job, period. As long as you're working to get that job, we'll be working with you with our job placement personnel. And all of these are given to you if you enroll in May. So again, stick around for the free gift, right? If you want to find out more, the link is right in chat. Just click on that and fill out the form. It's very, very brief. And once you fill it out, Bala Christian says, what is the price after 3% off? It's a great question. We have 12 different boot camps and they all have different prices. So as an example, I think if you do our most expensive one, you're saving $17,000. If you do our least expensive one, you're saving about $7,000. So it just totally depends on which one you do. Okay. So yeah, you'd have to talk to one of our admissions personnel and figure out which of the 12 boot camps is the right one for you. But whichever one you do, if you pay up front, it's 50% off. I hope that answers that question decently enough. All right. By the way, when you fill out that form, there's a series of steps about the Tech Academy. A bunch of videos, articles. It's not a bunch of them. It's pretty brief, actually, but it tells you all about the school, answers most of your questions. And you can even book a call with our admissions staff. All right. Kevin says, I don't see a login button on the site. It's not a login button. There's a form to fill out. Kevin, if you don't see the form at that, let me click on that link. Yeah, you should see this screen right here. You fill that out and it'll take you to the actual steps. Oh, this is awesome. So this existing users thing, let me go back to my deck. Some people, when they go to that link, they see a login screen, and that's because they've already got an account with us. And this just shows people how to actually log in. That's all. All right. So let's move on. Okay. I also want to mention that we do pay referral bonuses. So if there's people you think should be looking at the school, please let us know. Referrals have been one of the most successful courses. Our successful sources for students for years. So we've always paid a commission to referrals. So in a minute, I'm going to give you an email to get a hold of us about the free gift. You can email in as well and give us contact information about anybody you think should look at the school. And we keep track of that. And if they sign up, we send you a check for 5% of the tuition they paid, right? We already mentioned these books, but here's a little more detail. We have 7 technology publications, 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, our book called You Are Not Stupid, which is amazing, right? It's basically a written version of our computer basics course. It has all modern technology terms and concepts defined. It's even got a history of technology that shows you how we arrived where we are today. So our free gift, it's our project management handbook. Jack and I wrote this because it's one thing to learn how to code. It's another thing to learn how software gets made. How do you manage this process on the day-to-day basis, on a week-to-week basis? How do you actually coordinate to get software made? And it's a key thing for technology professionals to know, and it wasn't being explained very well. And so we wrote this book to explain that. If you'd like a copy of this book sent to your house, and this is for US only, I apologize, right? Grab the email address. This is important. We sometimes have people post this information in chat. We don't want you to put your contact information in chat. What you do is grab that email address, books@learncodinganywhere.com, and send us your name and your email and your mailing address. We will send you your own copy of the Project Management Handbook. You can also, include in there any questions. If there's a question you have that I didn't get to, just drop it in there. They send those on to me. And if you have people to refer, drop their name and contact information in there. And again, we'll keep track of that. I'll give people a moment who want to grab that email address. And I recommend getting the book. Like, it simplifies a lot of aspects of technology. All right, one of the final things I want to share is our link tree. If you're not familiar with Linktree, it's just an online service that stores all of your links in one location. And we have all Tech Academy links in there that are important. You'll see that URL in chat right now. And go ahead and click on that link that's in chat, and you'll see we have links to our free educational YouTube video playlist, links to our books and our dictionary. There's links to our upcoming meetups and all of our social media accounts. So I would ask you to follow us on social media, and please invite your friends to future meetups, classes like this. And I will say this, if you can share a link to the next event on your social media and tag us, you'll have a chance to win your own copy of You Are Not Stupid. I can't stress how valuable this book is. It's a book that I had wanted to be written my whole life. No one was writing it. So Jack and I spent 18 months putting this book together. It removes all confusion and mystery from the whole area of computers and technology. Give it to your elderly relatives, and you will no longer be their tech support person. And so again, all you have to do is share a link to the next event in your social media and tag us, and you'll be thrown in, like we give one away a week, and you have a chance to win it. All right. So first of all, thank you for attending. Super appreciate it, right? A reminder, if you filled out that form, keep going through the subsequent steps to learn more about our boot camps. And please, I want to see you at the next event. So check out our links and come to our next class. And thank you so much for taking time out of your day to attend the class, interact with me. I really love that. And I hope you have a wonderful evening.